I'm about to show you the demonstration of the projectile launched upward at an angle of 45 degrees. Remember, it's the yellow ball that has an initial velocity of 6.1 meters per second that will result in the ball landing, hopefully, very close to that X over there. And it's going to be launched from the projectile launcher that's right there. My daughter's going to do the launching, and I'm going to stand at that X right there, and it should go over my head. That's the point of maximum altitude of the projectile based on the calculations we had earlier. I'm going to set this back up. And I'm going to hope that it's pointed well enough that you'll be able to see the whole thing. It's kind of funny that to see a slow-mo video, I have to record it on my phone and then video the phone playing it back because my computer won't seem to run the slow-mo video. There it goes. There's the ball.
A little forward, just on your X, yeah.
Okay. Great. There's just two things more that I want to do with you on projectiles. Hopefully the other lectures and the PowerPoint presentations will guide you through the problems that you have that involve anything quantitative. These last couple of things are more qualitative and kind of fun. First question would be a clicker question if this were a regular class. And here's how I'm going to pose the question, and you can see it on this PowerPoint slide here. Let's say I have two life preservers, and I'm a lifeguard, and there's two people who need it at the same time. One person is further away from me, the other person is close to me. I don't want to show any favoritism, so I'm going to throw both life preservers at the same time. I'll throw it to the further person lower, and to the closer person higher, so that they don't get all intertwined while I'm throwing it to the people. The question is, which person will get the life preserver first? Person A, who's the closer one to me, or person B, who's the further one to me, given how I threw them. Remember, I threw the closer persons a little bit higher so that it wouldn't get tangled with the further persons, which I threw lower. But I threw them at the same time. Is it going to be person B, or is it going to be the same? Or question D would be, it's impossible to tell without more information. I'm going to do the demonstration for you in the next little bit. Okay, I have my two objects. You can think of them as life preservers. One of them I'm going to throw high, the other one I'm going to throw far. You're going to try to predict which one's going to land first, and then you're going to watch and see whether you were right. High, far. Do it again. High and far. Hopefully you saw that it was the higher one that landed last. It's because the time a projectile takes is a function only of how high it goes, not how far it's thrown. So you could throw something really far, it could land fast. But if you throw it up high, it's going to take longer. This last one is what I'll leave you with projectiles, and it's really a lot of fun. So I'm going to play it. Here it goes. Here's the person who's going to go down the water slide. Whoa, look at that. Here he goes. And he's off into the target. Clearly this was done before social distancing. And I'd like to leave you with that. I was told that that was actually staged. That didn't actually happen. But it gives you the idea of what maybe could be done with projectiles, where if you know exactly how they're going to launch, their initial speed and their angle of launch, you can predict where they're going to land. All right, next topic's going to be energy.